All right, so for the last concept we're doing factoring, it's solving equations that involve factoring. So these are the types of questions we're going to be dealing with. I just want to show you really quickly. Most of the stuff you've been doing thus far, if you factor it, let's say you got like x plus 3, x plus 4. Let's say that was your factored trinomial. This was usually our answer. This is an expression. We can tell it's an expression because there's no equal sign. As soon as you put an equal sign, it becomes a very different question. When we're dealing with equations, we can do something. If I say 10x is equal to 100, we can divide both sides by 10. The reason we can do this is because they're equal. If we do something to one side, we can do it to the other side and they'll still work out. This would become x equals 10. When we have questions like this, okay, when it's an expression, I can't just suddenly decide, oh, I'm going to multiply it by 3, because then it's different. But if it's equal to 10, I can say, well, I can multiply this by 3 as long as I multiply this side by 3 as well. This is going to be really important when we're solving these questions. So, let's say I got a question like this. Okay? The way we're going to solve it, and the way we're going to solve every question, is we're going to make it equal to 0. That's the key part. So whatever is on this side of the equation, I'm going to move it over so that I can then factor. So it's minus 2, so I'm going to add 2 to both sides. So it's going to be 2x squared plus 6x plus 2. Now we go through our factoring rules like always. The first thing we can do, they have a common factor, so I'm going to factor out the 2. X squared plus 3x plus 1 equals 0. Let's make this 3, sorry. 4 rather. There we go. Sorry, I messed up the question. Okay, so I factored it out, awesome. Now, because this side is multiplied by 2, if I wanted, I could divide this side by 2, and this would cancel out. But I'd have to divide on this side too. What's 0 divided by 2? Still 0. So we're left with x squared plus 3x plus 2. This can actually make questions easier to write because you can get rid of stuff like common factors. Now I can factor this. I'm just going to do it fast. It's going to be plus 2x plus 1 equals 0. Cool. So that's fully factored. Now we want to figure out what's the actual answer. So we're going to use a rule here that's kind of weird to understand. But what if I looked at this? If I have two numbers multiplied together and they equal 0, we know one of them has to be 0. Because any two numbers, if we did like 3 and negative 1, right? That's equal to negative 3. That doesn't work. The only way two numbers can multiply to give you equal 0 is if one of them is 0. Okay? So 1 is 0. So this is the same as what we're doing over here. We're saying this or this is equal to 0. So let's say x plus 2 equals 0. Okay, let's assume that. So if x plus 2 equals 0, that means it's really 0. Oops, sorry. That means that x is actually equal to negative 2. Because if you subbed in the negative 2, that would be 0. So if x equals negative 2, that means over here, the second term is going to be negative 2 plus 1. All right, that's not really important. But so we said, in order for this to be 0, x has to equal negative 2. Now the other option we could do is say, well, this one is going to equal to 0. X plus 1 equals 0. So really, that means that x is equal to negative 1. So what you'll notice is there's two possible answers. Based on this question, either x is negative 2 or x is negative 1. If you sub those numbers into the equation in for x, it will give you the answer equals 0. So, using that logic, most questions we deal with are going to have two answers. And the way we can tell those answers is by looking at what the factored remains are. That's really why we learn factoring, so we can figure this out. It's really easy to tell whatever this is. In this case, it was plus 2. That means the answer is going to be negative 2. In this one, it was plus 1, so it's going to be negative 1. There's some weird examples, but that's like the basic rule. So let's do another one. Looking at this, x minus 3 times x plus 4 is 0. That means either this one or this one is equal to 0. One of them has to be 0. So if this was 0, that means that x minus 3 equals 0. So really, x equals positive 3. That is one possible solution. Or if this one was 0, that means x plus 4 equals 0. So x is actually equal to negative 4. So we have two possible solutions. The last one I want to do is a word problem, very similar to this. Okay. Area of a rectangle sheet is 300 meters squared. Area equals 300. The length is 5 centimeters more than the width. So let's draw a diagram. This is the width. This is the length. The length is actually width plus 5 because it's 5 centimeters more than the width. So I'm going to write a polynomial expression and solve it. So we're saying area is 300. Area is the same as length times width equals area. Okay. The length, I'm actually going to write width plus 5. The width is just the width. And the area is 300. So now, that's my equation. That's my formula. I subbed in the numbers. This was length. This was length. This was width. This was width. And the area was 300. Now, let's actually expand it so we see what we get. Okay, so I'm going to do rainbows. Get w squared plus 5w equals 300. Again, we want it to equal 0. So I'm going to subtract 300 from both sides. So it's going to become w squared plus 5w equals minus 300 equals 0. That's our equation right now. Now, once we get it to there, we have to factor. There's no common factors. It's trinomial. So I'm going to do negative 300 and write out my factors. I cheated and looked ahead. It's actually 15 and 20. Gives me a difference of 5. So that's what I'm going to do. So my answer is going to be w plus 20, w minus 15 equals 0. These are the two that would multiply to give me that answer. So it's factored. Now I need to write this is the possible answer or this is the possible answer. One of these must equal 0. So for this one, w plus 20 equals 0. So w equals negative 20. Or for this one, w minus 15 equals 0. W equals 15. These are the two possible answers. Now, the question said, what's the perimeter? What are the dimensions? This is the width, right? So a width of 15 makes sense. That's cool. A width of negative 20 does not make sense. You can't have a negative number for a width. So when you're doing word problems, sometimes you have to eliminate negative answers that don't make sense. So this must be the only answer possible. So when I write my diagram, the width is 15. We said that the length was actually the width plus 5. So that means this is going to be 20. This is 20 and this is 15. If we want to find the actual answer, the perimeter is equal to 2 times the length plus 2 times the width. The length we said was 20. The width we said was 15. And we find the answer. I think it was centimeters, so it would be centimeters. This part isn't very confusing. The confusing part, I think, is writing the initial equation, thinking of something like this, w plus 5 or whatever, finding the two possible answers for what w is, and thinking, does that answer actually make sense? The last thing I want to show, it's not going to happen very often, but you can get weird questions like this. Let's say we had a factored question that looks like this. Okay? This one obviously is going to be x minus 5 equals 0, so therefore x equals 5. That is one possible answer. The other possible answer is over here. If you just look at this, you might think, oh, I know it's going to be negative 2, but be careful. When we have a number in front, like that one, okay, like this 3, it actually changes it. So we know 3x plus 2 must equal 0, so that means 3x is equal to negative 2, so x is equal to negative 2 over 3. So be very careful when there's a number in front, which won't happen often, but sometimes if you get a question written out like this, you'll have it. This is the other possible answer. So again, we have 2, because we had 2 fractions written out. It gave us these two possibilities. And that's it.